Okay children, good morning everybody, and I am Madhvi Saxena here with my new topic on Van de Graaff generator, and today we will discuss on this. Like, if you like this, I would please like you to like this, subscribe it, share it with your friends so that maximum of the students can be benefited. Now let us talk about Van de Graaff generator. This is the last topic of your NCERT book for the second chapter, potential and capacitance, right? And it is with some of the boards it is there, for some of the boards it is not in the syllabus. So whoever the students who require this can study through this video. Okay. Now let us talk about Van de Graaff generator. What is Van de Graaff generator? Van de Graaff generator is a device which is used to produce or which is used to create a high potential difference, right? Why? Because such kind of devices are normally used in nuclear reactions. What happens in nuclear reactions? We have to bombard some iron or implant some iron into another solid, or these kind of reactions takes place. And for that we need a very high energy, right? So what we have to do? We have to accelerate the charge with high potential difference. Now how to create that high potential difference? Obviously in our homes we don't have high potential difference, but for these kind of reactions we need high potential. So what we use a Van de Graaff generator so that we are in a position to generate a high potential with the help of a Van de Graaff generator. Now this Van de Graaff generator, let's talk about this. We have come to know about what are the usage, right? Then we will talk about the principles, that what are the principles on which it is based. See, it is based, that first principle of Van de Graaff generator is the corona discharge. What it says, that the rate of discharge of the charge from sharp points is much greater than the wider surface. If you have a surface like this and you want to discharge the charge through this, and secondly you have surfaces like this, like a comb, pointed points, then obviously the rate of the discharge of charge from the sharp points will be greater than the flat surfaces. First thing. Secondly, what happens? There are two spheres. One is the inner one, another is the outer one. Now we are transferring the charge from inner sphere to the outer sphere, right? And on the charge on the outer sphere gets collected. And we all know that Q is directly proportional to V. Higher will be the collection of charge on the outer surface, more will be its potential, right? Now, what it says, that whatever be the charge being collected on the outer surface, even the potential of the inner sphere is always greater than the potential of the outer sphere. The charge on the outer sphere is uniformly distributed. Definitely it is a high charge, so the potential outside is very high. So whatever be the charge outside, the potential of the inner sphere will always be greater than that of the outer. Because if it does not happen, then what will happen? The charge will start flowing from outer to inner. If the potential of the outer sphere increases, what will happen? The charge will flow from higher potential to the lower. So what we are saying, that the charge of the, whatever be the charge on the outer sphere, the potential is always higher for the inner as compared to the outer. Now let me tell you about the working. So these two are the principles. Now let us talk about the working. What happens here? See, this is a big sphere, right, on which we are going to collect the charge, and it has been packed in a concrete structure like this, right? These all are concrete structures. So what happens? We have a pulley here, and a conveyor belt is moving on this pulley, and this conveyor belt is made up of an insulating material, right? Then we have metal brushes here, and this is connected with a high tension battery. We have one more metal brush here which is connected to this big conducting sphere, and this is a metal brush here, okay? We have one stand here, as I told you about, that we use it for the bombardment of ions or implanting of ions kind of things. So we can accelerate this particular ion or the charged particle with high potential. So this is the ion source, and it is the usage of Van de Graaff generator. Okay, see what happens. Now this high tension battery provides a high charge on this metal brush, and as corona discharge says that the discharge of charge from the sharp points will be very high. So what happens? A lot of charge is being discharged from these sharp points of this metal brush or metal comb, right? This charge is collected on this conveyor belt. Why it is collected? Because it is not conducting in nature. It is insulating belt, so it does not allow the flow of charge through it. Now, this conveyor belt is going up. We can see this. So this charge is also carried with this conveyor belt and it reaches this upper pulley. Okay. Now after this what happens? Because of induction. You all have studied induction. What is induction? Like if here it is positive charge, then what will happen? Opposite charge will be generated, induced. What we use the word? Induced. On the nearer end of this metal brush, and the same charge will be generated on the farther end of this metal brush, this red color charge. Okay. So what happens now? Because of induction, the negative charge is developed on this end and positive charge is developed on the farther end. Now what happens? See, this positive, which is shown in blue, which comes from this conveyor belt, and this negative, they both neutralize each other, and when this belt returns back, now it does not possess any charge. And what happens to this one? Because it is connected with this sphere by a conductor, this charge which was being induced here, it gets transferred to the outer sphere. Okay. Now on the outer sphere it gets uniformly distributed. Again this conveyor belt will come, it is going to pick up the charge from here, again it will go up. By induction the same process takes place. The nearer end is induced with the negative charge, the farther end is induced with the positive charge. Both of them neutralizes each other and the positive charge by this conductor is transferred to the outer sphere. Okay. So we can see that charge is always getting transferred from the inner portion to the outer portion, whatever be the charge collected here. And when we are able to collect a big charge on the outer sphere, we are able to generate a high potential. And then this, by creating the potential difference, we can use this ion source and we can accelerate this charge particle. Okay, now this is all about the working, and I will also explain you why the potential of inner sphere is greater than that of outer. Now come to this side. See, we have one inner sphere and we have a charge on this, right? This is all non-conducting sphere and it is connected with an insulated stand. And we have a conductor sphere outside, right? What happens? The charge on the inner one is a small q and the charge on the outer one is capital Q. The radius of inner sphere is a small r and that of the outer sphere is capital R. Now what is the potential on inner sphere? The potential on inner sphere will be because of two things. First, its own charge and the potential that is on the outer sphere also, right? So this is kq upon small r. K small q upon small r because of this, and the potential on the outer sphere is K capital Q upon capital R, conducting sphere. And we all know by electrostatics of potential that whatever is the potential outside on the sphere, the same will be the potential inside also. This we have to study in electrostatics of potential. Okay, so it comes from there. So the potential on this surface is K capital Q upon capital R. The same will be potential inside also. So we have to add this for this one, for V of small r, right? So the total potential of the inner sphere becomes K small q upon small r plus K capital Q upon capital R. This is one thing. Now what about the potential in the outer sphere? What it says that if any charge is placed inside a conducting sphere, the whole charge is transferred on the surface. So what will be the total charge on the outer sphere? Small q plus capital Q. So what is the total potential? K small q plus capital Q upon capital R, right? This is what we have got the potential on the outer sphere. Now what happens? We have to subtract the potential. What we have to do? We will do subtraction V small r minus V of capital R. I mean to say that I am going to subtract the potential of capital R, the bigger sphere, from that of the smaller sphere. When I do this subtraction, you can see this kq upon small r plus k capital Q upon capital R minus k small q upon capital R and k capital Q upon capital R. K capital Q by capital R, k capital Q by capital R. We can cancel them both, right? Yes. So I am left with kq upon small r minus kq upon capital R. What is common? Kq. I get a value 1 upon r minus 1 upon capital R. Since small r is a smaller value, so 1 upon small r is going to be larger one. Okay, and this 1 upon capital R will be smaller. Okay, so what will happen when I subtract 1 upon r minus 1 upon capital R? I get a positive value because this one is greater and this one is smaller. So in that case, I get a positive value. This proves that potential of the smaller sphere is greater than the potential of the larger sphere. So this is what we have to prove into this. So I think this finishes your Van de Graaff generator. We have learnt about the construction, the working, the principles, and you can go to this and the diagram. So in case if you find this question, you can get full marks if you write all these things, right? Okay. Thank you. Even if you want, we have our own app for Potential Institute Kota. So if you want to subscribe, if you want to upload that, download that, you can do it, and in that you will get the written content also. So for that you will have to download my app also. Okay, thank you.